This is the BrainChip Podcast. Hear from our thought leaders about neuromorphic computing, beneficial AI, and how BrainChip's Akita is pushing AI to the edge. This podcast is a place for investors, practitioners, and anyone interested in the future of AI.
Hello, and welcome to the 30th episode of BrainChip's This Is Our Mission podcast. I'm Nandan Nayampally, Chief Marketing Officer and Head of Product here at BrainChip. And today, we'll explore intelligence at the edge with another esteemed guest. Ian Bratt, who is well known in AI circles, is a fellow and Senior Director of Technology for the Central Engineering Group at ARM. Ian has an extensive background in all forms of compute, having worked in CPU, GPU, and memory systems, but in particular, he has been the lead technologist of ARM's Neural Processing Unit. Welcome, Ian.
Thank you, Nandan. Thank you for having me.
It's great to reconnect with you. I believe Jem Davies, the former lead of ARM's machine learning unit, was a guest a year or so ago. And we continue the exploration and collaboration with ARM as we both enable the edge AI trend, which, as everyone knows, is evolving at breakneck speed. You have been at the forefront of AI designs over a broad range of market segments, but clearly I'd like to put the spotlight on edge compute and intelligent services delivery. So while most of the buzz and investment seems to have been on the cloud, even leading lights like OpenAI's Sam Altman mentioned earlier this year that even large language models won't stay on the cloud entirely, but smaller, more compact versions will emerge rapidly that are more amenable to the edge. I'd love to hear your views on that.
Yeah, so I definitely like to echo your point about the explosion of edge AI. I think, the way I think about AI from a compute perspective is that the demand is essentially insatiable at all levels of the stack. And so therefore, if you can do it on the edge, then it will be done on the edge. So there's huge demand to basically enable significant AI workloads on the edge. I think, Altman's comment about seeing optimized and smaller models in the future, I think is definitely true. And I think if we look at the past history of model development, that roughly rings true. Although I think there's a bit of a nuance to it. So I think what we have seen in the past is there will be a breakthrough. So there'll be a breakthrough for some new use case. And there will be a neural network that satisfies the requirements for that use case. And then you see kind of a phase of optimization. And that makes the model much smaller, much more optimized, and more amenable for deployment on the edge. And just deployment in general, right? If you can do it with less compute, what's not to like, of course. But I think that process is happening in conjunction with this ever-increasing model size. So we see a big model, and then we see an optimization, and then we'll see a new breakthrough with an even bigger model, and then more optimization. And we kind of keep seeing that repeating. So, on the vision side, we start Inception V3 was a big deal, and then MobileNet, significantly smaller, with excellent performance. I think large language models, we definitely saw some big improvements from the original GPT type work to the smaller models. So I think that trend will continue. There'll be a breakthrough and then an optimization phase, but that general trend of just more and more compute, I think, is still holding. But there's points along the way where engineers kind of pick off and optimize the networks.
Yeah, that's a fair observation. And a common theme here is that AI models get more complex. And they're also, as that happens, there are more compact versions of these that emerge. For example, 4 years ago, transformer models were huge, and they continue to get bigger. But now you have such more smaller models or smaller versions for edge devices like vision transformers and the tiny vision transformers. We will soon have specialized use cases, as you say, for LLM models as well. And speaking of which, do you have any bets on use cases that will drive some of these optimizations?
I've always been a bit reticent to make specific bets because a lot of the way I think of these use cases is not it's not about some new shiny use case that maybe didn't exist before. It's really about making existing use cases better. So I think like in the edge, things like classic, vision and audio processing has been around for a long time, but we've been very limited in what we can do. But with this continued advancement of neural network technology and the enablement of the underlying platforms, we're just going to be able to make those experiences much, much, much better, step function in performance. So that's kind of the way I think about it, is just kind of a rising tide that lifts all boats.
Well, that's a fair assessment. See, on the edge, if we look at it, keyword spotting and visual wake word were just the starting points, right? And soon graduating to something that can do more comprehensive inference of specialized, let's say, phrases, or adding vision to the same edge device. This still needs models to be more compact. Now, speaking of which, there's a large set of intelligent technical and business minds trying to bring, what should I call it, this condensation, if you will, of the model size. For example, the Llama project tries to do that, and there are numerous others. Have you seen a lot of activity for these kinds of things on ARM platforms? Clearly, smartphones are already embarking on this expedition. Do you see the same trajectory like Llama coming down to other edge devices?
Yeah, so kind of question specifically on kind of the generative large language models being pushed to the edge. Absolutely. And I think that is there are multiple forces driving that from both directions. So one is from the edge perspective, those use cases like maybe an auto completer or some sort of chat experience on your edge device. The latency is very important, and there might be privacy concerns. So if you can do that on the edge, that's great. On the other end, it takes significant compute and storage to run these models. And if every single device on the planet is now using large language models a few times a second, and you send that to the cloud, there's just nowhere near enough cloud to handle all of that. So those competing forces, so those cooperative forces, both from the cloud, actually unable to handle all that compute, plus the desire for having it on the edge, I think are working together to make that happen. So I think it'll definitely happen.
That makes perfect sense, right? We are also seeing a consistent theme here, and everybody agrees on it. I mean, you may clearly have better insight, but as rough numbers, I've seen that a ChatGPT based search is about 10 times the compute cost of a regular search. And that puts a huge tax on a Gen AI service or LLM service, which, probably is why Altman's statement is that you need to do more at the edge to make it economically sustainable. Not to mention, as you say, the need for privacy and security and real-time response.
Yeah, I think that's a great way to look at it. And when you start thinking about all of the scenarios that could be improved with LLMs, like every time I'm writing an email, anytime I'm doing anything on my local laptop or on my phone, that could be calling into LLMs. And that's just not scalable to send all of that to the cloud. That just won't happen.
Since we're on this topic of areas that are getting a buzz at the moment, what are your thoughts on multimodal edge AI?
I think that's inevitable, but I do not have a concrete idea for how that will manifest. I think if you think of edge AI systems as they're primarily often sensing systems that are making some decisions and providing feedback, determining when to notify somebody of something or when to log an event. And in those sensing systems, the more modalities of sense, the better the result. So I think we will definitely see that in that trend continue in edge AI, but specifically how, I'm not quite sure. But I think yeah, that will happen.
Well, from an investment perspective, I mean, that's where dollars are going, which really brings me to the point that the three V's, as we call them, vision, voice, vibration, and the ability to do all of these on one edge device is where I feel most of the people want to go. Is that a fair statement? And if so, what are the key challenges and how are you addressing them, both at ARM and through your partnership and ecosystem?
Oh boy. So it's a great question. And so just to play it back so I make sure I understand, you're kind of saying in a future where the voice, vibration, and vision aspects are kind of working together in edge systems for multimodal. What are the key challenges there, and how do we enable that? Yeah, I think from the I'll take the enablement bit first. From the ARM perspective, a lot of it is around. I don't want to say business as usual because that maybe trivializes it, but it is around just basically providing more energy efficient compute, right? Like that's what the ARM ecosystem does well. So providing more energy efficient compute, the more that's capable in those envelopes, then the more you will be able to express in those systems, and the richer problems you'll be able to solve. I think the key challenges there probably are around the practicalities of data collection and designing your neural networks with the right data such that they're robust and can handle all sorts of different scenarios. So I think a lot of the challenges are really around the applications area, around data and application design.
Well, that's a great segue and jumping off point to the fact that it's the software and ecosystem to some extent, more than just the efficiency of the hardware itself that is needed to make AI really successful. Of course, you need to have really efficient systems, but you need the software and the applications to fully utilize it. And the data that goes into these services needs to make these services viable. Give us a little insight on how ARM is working on NVIDIA's Tau or on the Cortex-M and Ethos platforms. And what does that mean for the market? And how do you help developers do low-code or no-code type applications and help get services moving closer to the edge?
Yeah, that's a great question, and thank you for mentioning NVIDIA Tau. So going back, I think I want to say almost like 6 years ago, we started some work within ARM, and the vision of the work was a tool where you would input your data and you would tell the tool, oh, I'm running on this edge device. And then the tool would do some compute for a while, and out it would spit an optimized neural network for that data for that device. So subject to the constraints of the device. So small, energy efficient. So that was kind of the vision of this work we started a long time ago. It's so easy to articulate a vision like that. And we were so wrong in terms of the state of the technology to enable that sort of tool. So yeah, we could kind of get some things to work, but it would take an army of PhDs turning knobs and cranking levers to get anything out. So that automated vision flow turned out to be very, very hard to achieve. And I think a lot of companies have been realizing that, and I think it's just going a bit slower than we had expected, but it is happening, and we're now starting to see stuff in the ecosystem like NVIDIA Tau, where if you constrain the problem and say, well, I'm just going to support these certain networks, and I'm just going to support these sorts of optimizations in the search space, then yeah, you can create some optimized models that might be better suited for the edge. So I think, like everything with engineering, the real path forward is constraining it to a simpler case, providing that tools, and then over time we'll get more and more towards that automated vision of the kind of no code push button flow to get an optimized neural network. But I think it will take a long time for that to happen. So I was definitely wrong in how quickly I thought that would manifest.
I think the famous adage of overestimating how much technology can do for us today or tomorrow or within a year, and then underestimating what it can do in 10 years. I mean, the applications at the edge, I don't even know what we'll see in 10 years, but looks like we're rushing too hard and hoping that'll happen in just 1 year.
Yeah, exactly.
To that effect, we had Zach Shelby, CEO of Edge Impulse, on our last podcast. And one of the key topics we had discussed was how to make Edge a first-class citizen in terms of AI development. How do we enable what is being done on the cloud or the network edge in optimizing models and frameworks that are fully fledged out to the edge? And that is Edge Impulse's model, trying to build that developer platform for the edge. And the area that is interesting is because AI models are only as good as the data that is used to train it, the bigger challenge probably is how do you make that data work efficiently? Perfect. Is that a fair statement? And if so, do you see a collective path for improving it? Are there known ways of making it better? Knowing that far edge devices that are close to sensor and have much more limited compute and much larger variety of types of models and intelligence needed have to actually scale to deliver those services. I know this is a little bit more of a nebulous or hand-baby question, but this is a pretty big challenge to make that all work well.
Yeah, I agree. I think that's a huge challenge, and it's, I think I've heard the phrase data is the new oil, and I think the data needed, like you said, for these edge devices is particularly hard to extract and refine. So I think that is probably an unsolved problem, or I'm sure lots of folks are trying to solve it right now. But I think that's very important, just as important and as challenging as actually deploying all of the AI on the edge. Getting that clean edge data is going to require lots of innovation and probably entrepreneurship to get the ecosystem to the point where that data is out there that people can use.
One of the ways to think of innovation that is needed at the edge is not just about the hardware, software, and models to make it more efficient, but it feels like the investment in tools on how to build the models more effectively with lesser data, right? And this brings me to one of my favorite statements from the old ARM vault, where Mike Muller, the founder and former CTO of ARM, said, "There is no big data without little data."
Yeah, definitely. I think I love that. I love that saying. And I think, also an interesting aspect of this angle is that often this data is, even if you're getting it, it's often noisy, or, you're generating it on maybe lower cost sensors. And so there's always going to be a need in these platforms for kind of more classical computing, just to process that data, get it ready before it kind of feeds into the neural network. And that's something, it's easy to lose sight of that aspect of the pipeline. But it's very important in these edge systems to kind of think about, we call it sometimes the neural network sandwich. So the neural network's in the middle, but there's often, compute before and after to kind of process the data and also interpret the results.
In a similar mindset, I guess it needs to be applied to when we get much closer to the sensor, to have smarter sensor data and have it utilized well to make our results better. Yeah, I love that visual. And this is what we're seeing too. One of the key challenges that we see is, in fact, this neural networks sandwich, as you call it. We see that the bread slices are much thicker than the filling.
That's right. And nobody likes a sandwich that's all bread.
So how do you see the neural network getting smarter to reduce the amount of, what could I say, the metaphorical bread that it needs? Do you see the trend happening across the industry? Because we certainly see our customers saying that the less pre-processing I need to do, the better it is, the less post-processing I need to do, it's also welcome. So do you see it across the board that networks are becoming smarter to reduce the amount of pre and post-processing needed?
Yeah, I think that's definitely something we're seeing as well. So you kind of think of the neural network is essentially like eating into those classic algorithms that are the pre and post processing. I think in some scenarios the pre and post processing is sufficiently well understood. There's sufficiently sophisticated classical algorithms that are very energy efficient. And we shouldn't throw those away and do it with a very inefficient neural network just because we can. So it's around kind of finding that right trade-off.
Balance.
Yeah.
Cool. I mean, if I look at that trend, what kinds of form factors are you expecting? Let's say I look ahead to 2030. Do you see devices that can run for years on battery, or smaller embeddable devices that can do intelligent computing needed and still survive on energy harvesting? Do you see these types of possibilities in the next 7 years?
Yeah, I do. I think I think it's going to require, riding the innovation curves across all aspects of the stack, technology, battery technology, transistor technology. I think all of that coming together, and then I think in some of these sensor systems, they might be always on, but you can have a hierarchy of processing, right? You can have very rudimentary detection to determine whether or not you should then wake up something that's a little more sophisticated, which could then determine whether or not you wake up an even more sophisticated device. So I think that style of system can be very, very energy efficient in the long term. And if you look at the trends around technology scaling, then yeah, I think that will happen.
Effectively, what you're talking about is akin to TinyML, right? So TinyML started a few years ago. I think you guys were early proponents of it, supporting always on, very simple stuff at the edge. MLPerf Tiny Benchmark started with that approach to do only very simple things for always on processes, especially the smallest Cortex Ms. But as you see edge evolving, do you see the market need for more complex use cases, which may still have to be always on, but bring up more compute? You're doing a lot more on the edge. And so how do we see this growing out from a tiny ML benchmark set to maybe a small ML benchmark set?
Yeah, that's a good question. And it's funny, you asking it reminds me of, so in the early days of TinyML, where we were having some committees to organize the first workshop, and we spent hours arguing about what does tiny mean, and just is it the 100 milliwatts, is it single milliwatts, is it a single watt, and just hours and hours talking about how tiny is tiny. And I think at the end it was we kind of gave up and said, well, people will know what tiny is. But I do think the benchmarks you're talking about will be needed, kind of growing beyond tiny. But I think the ecosystem is on the right track in that a lot of the TinyML work reflects kind of the status of what's in silicon today and what people can take and then benchmark. And as those platforms improve in their capabilities, we will see the benchmark suites advance and expand in scope, kind of following that trend.
And that is a fair point, right? Benchmarks will follow this trend. That there are consortia working on it. Now, extending this into the ecosystem side, the challenge for Edge AI is that it's very fragmented. So do you see enough of a push from the industry for standardization of some sort? And if so, what are the challenges that they need to solve to get that baseline set?
Yeah, so that's the $1 million question. I completely agree that the standardization around Edge AI is something that is holding back the ecosystem. And I think at the end of the day, it's worth thinking about, like, well, what does good look like, right? So I think what good looks like is a data scientist using JAX or PyTorch in AWS or some other environment to develop their model. They have some sort of automated tool or semi-automated tool that says, yeah, this will run on your edge platform, or no, it won't, make this change, and yes, it will. So I think that's what good looks like. So then to actually build to that point is really the challenge for the community. And I think there's a huge demand, and because there's a demand, those gaps that are in between what good looks like and where we're at today will be filled by different companies in the ecosystem. And I think leadership from companies like ARM and others coming up and saying, like, hey, this, you should support these operators. These are the frameworks you should support. This is where you should put your effort. I think the leadership from companies coupled with kind of natural development and entrepreneurship to plug those gaps, I think we will get there. But again, I think that's another one of those that will take a while.
And in fact, this was my lead into the fact that soon the embedded world, as we know, there's a need for best of breed and specialized implementations as these applications evolve. Of course, ARM has its own set of products for processing any type of activity, including AI. But you could see a common customer combining a neural processor for BrainChip with a Cortex M85, which has its own vector engine, to create a pretty compelling, small footprint, low power platform for Edge AI. Now, always ARM has been a leader in creating ecosystems while providing their own technology and collaborating with other providers. As you look ahead at AIoT, or the artificial intelligence of things, do you see this trend as well of having a lot of diverse offerings? Is that growing or consolidating?
I think it's like any other new space where we're seeing kind of an explosion in offerings, and then we'll see consolidation and convergence. Actually, which part we're on there now, the upslope or the downslope, I'm not sure. But
yeah, it's all a cycle. It will start again.
Yeah, exactly. And I think that there are things that ARM is doing. We've been working on this project called the Tensor Operator Set Architecture, TOSA, for several years, which is a stable layer. It's actually a tensor dialect with an MLIR, which is a compilation framework for building compilers. So it's a spec-backed definition of what we think is an important MLIR, and then others are free to implement that specification in their NPUs. And if an ecosystem can consolidate around standard layers like that, I think it will help a lot in terms of providing stability for Edge AI, but it'll take time for these things to develop.
Yeah, I can't believe we've already run through over 30 minutes. It's been a pretty stimulating discussion, and to bring it to a close, I'd like to ask you a question that may be either lighthearted or deeper, depending on how you take it. So, do you see a singularity in our lifetime? Do we get to AGI by 2050?
I do think we will get to AGI. I do. Um, so yeah, I am one of these people that of the folks that believe we will hit AGI. I am a techno optimist. There's two views of the future. There's the dystopian Blade Runner view, and then there's the Star Trek view where there's replicators and it's a world of abundance. And I'm in that optimist camp, the Star Trek view of the future. So I'm looking forward to it.
To those listeners who may not know what AGI means, AGI is artificial general intelligence. And to explain that, I'll just pass the baton back to Ian to take his view.
Well, so I guess that's a good question. That is one of the great questions is once you've built such a thing, how do you provably know it's actually AGI? But the idea is something that an artificial system that generalizes across many different tasks, as good, if not better than a human, and is indistinguishable from a human from a computability and generalizability perspective.
Cool. It is a very positive note for us to end on and set the rest of us that were worried about a dystopian or a Terminator robotic control side of artificial intelligence at rest. So I will take this opportunity to thank you, Ian, for spending your valuable time and insights with us. And I look forward to collaborating with you and seeing what interesting things ARM has lined up for the future of Edge AI. Thanks again.
Thank you, Nandan. It was great talking to you. Thanks a lot.
Thanks for listening to the BrainChip podcast. Please remember to rate and review on your favorite podcast platform.